review of the Ingenuity lesson, multiplying radicals. So for our first example here, all we're going to do is we're going to find the products of all of these radicals here. So when you multiply, you need to make sure that you have the same root, meaning you can't combine a square root and a cube root. So on this first one here, whenever you have the square root of something times the square itself, essentially, so square root of 3 times the square root of 3, the answer is just 3. The reason that is if I show you how we actually multiply it out, you would have the square root of 3 times 3, which is the square root of 9, which is 3. So like if I had root 7 times root 7, it's 7. Root 12 times root 12 is 12, so on and so forth. So if it's bigger than just a square root, so like here we have the cube root, so for it to work, you have to have 3 of them, because then what happens is we have the cube root of x times x times x, which is the cube root of x cubed. Those cancel and you just get x. So like another example, if I had something that was with the 4th root of whatever, 2, let's say, for it to be just 2 at the end, you need 4 of them. 1, 2, 3, 4. And if you multiply all of those out, you get 2. The 4th root of 2 times itself 4 times. Okay, so on this next one here, we have the 4th root of 4x squared times the 4th root of 4x squared. So same root here. So I can combine them into just one big 4th root. So if we multiply the numbers, 4 times 4 is 16. And then multiply the letters. X squared times x squared is x to the 4th. The 4th root of 16 is 2. And then the 4th root of x to the 4th, those essentially cancel and you just get an x there. So 2x is our final answer. Okay, so on this one we have the square root of 12 times the square root of 18. So we can combine that into the square root of 12 times 18, which is 216. So let's see if we can simplify it. So are there any perfect roots perfect squares that go into 216? So numbers like 4, 9, 16, 25, 36, and 49, and so on and so forth. And 36 goes into 216. So I can break this up into the square root of 36 times 6. And the square root of 36 is 6. So our final answer here is 6 root 6. Okay, so on this next one, we're going to have to distribute this 3 root 2 to both parts. So what we're going to do is you're going to multiply the numbers in front, and notice they're all square root symbols, so then we can go ahead and combine the part that is underneath the radical. So let's see, 3 times 5 is 15. The square root of 2 times the square root of 6 is the square root of 12, minus 3 times 7 is 21. Root 2 times root 3 is root 6. This one here we can simplify. There's a perfect square in 12. So I can rewrite this as square root of 4 times the square root of 3. And the square root of 4 is 2. And then you can just multiply the numbers in the front. So 15 times 2 is 30. Now these ones we cannot combine because we have the same root, but when you're adding and subtracting, you also have to have the same number underneath the radical, and we don't have that. So these are not like terms and they need to stay apart. Okay, now on this one, we need to multiply, but we do not have the same root. We have the square root of cube root and square root. So what you have to do is you have to rewrite them as rational exponents. And just as a reminder, write it down here. Square root is the same as having a rational exponent of a half. Cube root is a third. 4th root is 1/4, and so on and so forth. So on here we have the cube root of 5, so I'm going to rewrite that as 5 to the power of 1/3 times the square root of 2, so 2 to the power of 1/2. So what we have to do is we have to get common denominators. So the least common multiple of 3 and 2 is 6. So I need both of these to be 6s on the bottom. So to have made this a 6, I had to multiply it by 2. So whatever you do to the bottom, you do to the top. So this is 2 6. This one, we'd have to multiply the top and bottom by 3. So 3 6. So if I rewrite them in radical form, the number on the denominator tells you what the root is. So this is the 6th root. The number on the top is the exponent that you're going to attach to your base 5. So the 2 sticks with the 5, and the 6 tells, or the denominator tells us what the root is. So the denominator tells us what the root is, and then this 3 here, it's going to stick with the 2, so it's 2 cubed, like that. Now we can go ahead and combine. Well, let me simplify first, I guess. Cubed is 8. So now we can put them together. And, oops, sorry. So we end up with the 6th root of 200.